Welcome to the DIY Honda Garage channel. The DTC P1658 indicates a malfunction in the ETCS control relay on system. This diagnostic trouble code pertains specifically to the Electronic Throttle Control System, ETCS, in the Honda Pilot vehicles manufactured from 2016 to 2022. The ETCS is crucial for regulating the engine's throttle position, which significantly impacts engine performance and efficiency. When this code is triggered, the vehicle's computer, known as the Powertrain Control Module, PCM, has detected an anomaly in the relay that controls the ETCS. The relay board itself is located near the engine compartment and works to facilitate the communication between the throttle and the PCM. If this relay fails, it could lead to a range of performance issues, necessitating a thorough diagnostic process to pinpoint the exact failure. DTC P1658 describes a malfunction within the Electronic Throttle Control System, ETCS, control relay, indicative of an on failure. The ETCS relay plays an integral role in managing the throttle position by relaying appropriate signals from the accelerator pedal to the engine control unit. Its location within the engine compartment is strategic, allowing for proximity to both the throttle body and the PCM for efficient communication. The relay board is essential for maintaining the correct functionality of the throttle and ensuring that the vehicle operates efficiently under various driving conditions. A malfunction here could lead to symptoms like reduced engine performance or stalling. It's crucial to perform a thorough check to ensure that all components connected to the relay are functioning correctly. Possible causes for the DTC P1658 include several issues that can arise within the ETCS. First, poor connections or loose terminals at the relay circuit board, or PCM, could lead to intermittent failures, making it difficult for the system to maintain effective communication. Second, if the relay circuit board itself is faulty, that could cause a direct malfunction of the ETCS, preventing the proper relay of signals. Third, there may be shorts in the wiring harness, particularly in the DBW RLY drive-by-wire relay line. Such shorts can disrupt the flow of electricity necessary for the throttle to operate. Each of these causes needs to be considered during diagnostics to isolate the root problem effectively. The symptoms associated with DTC P1658 are primarily related to the performance of the throttle in your Honda Pilot. Owners may notice reduced engine performance, where the vehicle does not respond as expected when the accelerator is pressed. Throttle response issues are another common symptom, causing delays or erratic behavior in acceleration. Additionally, some drivers may experience stalling or surging, particularly when trying to maintain speed or during slower driving conditions. These symptoms can greatly affect the vehicle's drivability and overall safety, making timely diagnostics and repairs crucial. If any of these symptoms are present, it reinforces the need to investigate the DTC thoroughly. In the first step of troubleshooting DTC P1658, start by turning the vehicle to the on mode, which activates the vehicle's electrical systems without starting the engine. Next, navigate to the inspection menu using the Honda Diagnostic System, HDS, selecting the ETCS test option. This test will allow you to assess the status of the relay circuit. If the relay circuit is deemed okay, it suggests that the system may be functioning intermittently at that moment. And you should further check for poor connections or loose terminals at the relay circuit board and the PCM. However, if the test indicates a failure, this confirms that you need to proceed to the next troubleshooting step for a deeper investigation. The second troubleshooting step requires you to turn the vehicle to the off or lock mode. ensuring that all electrical systems are shut down before proceeding. After this, the next task is to remove the relay circuit board for testing. This is critical because you need to ascertain the condition of the relay itself, which can often be the source of the malfunction. Using an appropriate testing method, ascertain whether the relay is functioning correctly. If the relay is determined to be faulty, it will need to be replaced. However, if the relay passes the test, you will then proceed to the next step in the troubleshooting protocol to continue diagnosing the system. For the third troubleshooting step, again make sure the vehicle is turned off or in lock mode to ensure safety. Here, you will jump the SCS service check signal line using the HDS, which involves utilizing the diagnostic tool to create a bridge for checking circuitry. Allow more than 1 minute for this step, after which you'll disconnect the PCM connector A51P. The aim is to check for continuity between specific test points. In this case, test point 1 is located at PCM connector A, pin 13, and test point 2 is at the body ground. If there is continuity between these points, it indicates that there is a short in the DBW RLY wire. This finding will require further investigation to locate and repair the short. Conversely, if there is no continuity, it confirms that the DBW RLY wire is functioning correctly, allowing you to move on to the next troubleshooting step. In the fourth step of troubleshooting, first, disconnect PCM connector C, 51P, to isolate the circuit from the rest of the vehicle's systems. Then, turn the vehicle to the on mode, which will activate the electrical systems necessary for this test. Your next action is to measure the voltage between specified test points. Test point 1 is at PCM connector C, pin 4, and test point 2 is at body ground. If the measurement indicates battery voltage, it signifies that there is a short to power in the IG1M, IG1, ignition 1 main, drive-by-wire, leading to faults that need addressing. On the other hand, if the measurement does not reveal battery voltage, it confirms that the IG1M, IG1 wire is functioning correctly. In such a case, it becomes necessary to refer to any authorized service information related to the DTCs or symptoms being diagnosed, or to consider substituting with a known good PCM for further testing. After completing repairs related to DTC P1658, it is essential to perform a comprehensive verification to ensure successful resolution of the issue. Start by conducting a test drive under various conditions to assess the effectiveness of the repair. Pay close attention to the throttle response, ensuring it functions as intended without any delays or irregularities. After the test drive, scan the vehicle's systems again to confirm no reoccurring DTCs are present. This will verify that the previous issues associated with the ETCS control relay on malfunction have been fully resolved. A thorough final verification process is crucial for vehicle safety, performance, and customer satisfaction. Preventive maintenance will play a significant role in mitigating issues similar to DTC P1658 from arising in the Honda Pilot. Regularly inspecting wiring harnesses and connectors related to the ETCS can help identify potential problems before they escalate. Pay special attention to connections and terminals. Loose or corroded connections can lead to intermittent failures. Maintaining relay connections and ensuring they are clean and secure can prevent electrical issues from developing. In addition, seeking professional diagnostics if you notice any symptoms related to throttle response can lead to early identification and correction of potential faults. This proactive approach not only preserves vehicle performance, but also extends the overall lifespan of crucial components. To conclude, DTC P1658 highlights a malfunction in the Electronic Throttle Control System relay. specifically indicating an on failure that needs addressing. Following the outlined troubleshooting steps is crucial to accurately diagnose and correct the underlying issues present. It is essential to not only focus on repairs, but also to conduct thorough final verifications to ensure no DTCs persist and the throttle operates smoothly. Incorporating preventive maintenance measures can further enhance the likelihood of avoiding similar problems in the future, promoting both vehicle reliability and performance. Understanding this code and its implications can empower owners and technicians alike to maintain optimal functionality in the Honda Pilot. Please like and subscribe to the channel. See you next time.